Hi everyone, today we're going to be looking at the product quality verification Do-More PLC sequencer. We will be demonstrating counter sequencing logic on the Do-More PLC simulator and EasyPLC. EasyPLC software suite includes a machine simulator named Machine Simulator MS. It has a variety of machines that can be programmed and customized. One of these machines is the body car quality verification machine, which utilizes a camera and a collaborative robot, cobot, to check the body and a second cobot to mark the inspection pass. If the inspection fails, a robot will be used to return the car body. The virtual machine will be programmed using the Do-More Designer PLC Simulator. To establish communication between the simulator and the quality verification machine, we will use the Do-More Designer PLC software and connect them via Modbus TCP or Ethernet. This will enable seamless communication and data exchange between the two systems. To demonstrate the programming of the virtual machine, we will follow the 5 steps to program development. These steps provide a structural approach to ensuring the efficient and effective development of ladder logic program. By following these steps, we can ensure that the program meets the specifications and functions as intended. Now let's dive into the first step of our program development process. This step involves defining the task of our car body product quality verification. By clearly defining the task, we can establish the objectives and requirements that the program needs to fulfill. This will serve as the foundation for our subsequent steps in the process development. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. Step 1. Define the task. The first step of a Do-More or any PLC program development is determining what must be done. Start the EasyPLC Machine Simulator or MS. Select the Start button on the main page or select Machines from the main menu at the Machine Simulator window. All of the available machines will now be displayed. Click on the 12 Product Quality Verification. This is the example we will be programming. To the left of the screen, information will be displayed on how the car body quality verification machines need to function. This system uses 2 collaborative robots, 1 big loader robot, 2 conveyor lines, 2 conveyor stops, 2 photo eyes, 1 scanning camera, and 1 print marker. Use the cobot with the camera to check if the car bodies are correctly finished, which is the hood mounted. If so, use the second cobot to print a check mark. If not mounted, use the loading robot to return the car body to the return conveyor. The cobots and robot move with digital inputs and output signals. The car body quality verification simulator has a demo mode for this built-in machine. This allows you to watch the operation of the quality verification machine. Select the demo mode. The demo mode will now show you the basics of the quality verification operation. Move around this 3D virtual environment. The icons on the top of the window allow you to move around this 3D environment. The first icon is the default selection. This will enable you to move around without bumping into the components. The last icon will automatically show you around this virtual environment. The first mode will mimic a person in your 3D learning world. The third person will show you an operator and their relationship to the machine. Once we understand what must be done, we can move on to the next step in our developing the Do-More PLC ladder logic program. Step 2. Define the inputs and outputs. While still in demo mode, select View I/O at the bottom of the Machine Simulator window. This will display the inputs and outputs required for this product quality verification. The EasyPLC quality verification Do-More example will require 29 digital outputs and 18 digital inputs. The camera result will require 1 analog input to determine if the car hood has been attached or not. If you are unsure what an output or input is doing, start the product quality verification in start mode. Select the View I/O at the bottom middle of the Machine Simulator window. You can manually run the product quality verification without any code or PLC connected. Clicking on the outputs will allow you to turn them on manually. You can then monitor the inputs to see their operation. Move around this 3D environment and see the I/O and items from different angles. Clicking on the analog will call up the analog I/O for you to monitor and interact. The reset button on the bottom of the Machine Simulator window will reset the machine back to the start. The Do-More series of PLC uses a fixed Modbus memory area. This can be seen in the following chart. Step 3. Develop a logical sequence of operation. A flowchart or sequence table is used to understand the process that must be controlled fully. It must also answer questions like this. What happens when electrical power or pneumatic air is lost? What happens when the inputs and output devices fail? Do we need redundancy? This step is where you'll save yourself a lot of work by understanding everything about the operation. It will help prevent you from continuously rewriting the PLC program logic. Knowing all these answers up front is vital in the development of the PLC program. Our Do-More product quality verification machine can be broken down into 3 sequencers. Conveyor 1 sequencer will allow car bodies to enter the inspection station. The car body will be positioned at Conveyor 1 stop. A camera on the collaborative robot is used to determine if the car hood is present or not. If present, the body is marked by a second collaborative robot and sent out to the inspection station. If the hood is not present, then the Conveyor 1 resequencer will wait until the car body is picked up by the robot and moves to the home position. The camera returns to the home position and the carrier is sent out of the inspection station. The robot sequencer 2 will pick up the car body without the hood or defect and transfer it to the empty carrier on the returning Conveyor 2. Conveyor 2 sequence will allow an empty carrier to enter the inspection station. If the robot places a car body onto the carrier and returns to the home position, the carrier with the defective car body will exit the inspection station. A PLC programmer must know everything about the sequence and operation of the machine before programming. Ask questions or view existing documentation to ensure you know the logical steps to the machine's operation. Step 4. Develop the Do-More PLC program. Writing the ladder logic code for the PLC programming example will be the next step in our program development. Detailed information on the Do-More PLC and the simulator can be found here. We will be using the Do-More simulator with our EasyPLC machine simulator. Counters will be used for the sequencers in our ladder logic programming example. It is important to understand how this is achieved so that you can easily read the PLC code. Incrementing the counter is done by comparing the current count value and the conditions or inputs required to advance the counter step or sequence. After the last step or increments, the counter is reset, which resets the sequence. We can easily control the sequence when developing ladder logic code by placing normally off contacts so the counter will not advance the next step. Outputs are activated by comparing the current step. If the outputs are activated multiple times in the sequence, the comparing steps are placed in parallel. The following is our Do-More ladder logic programming example with 3 counter sequencers. We will see that ladder logic does not have many rungs and is easily to troubleshoot and program. The first 4 rungs of the Do-More quality verification program will create bits to indicate that the photo barriers are okay. You will see the conveyor sequence steps from the counters that will allow the product to pass through. Here are indication lights for the machine. The green light will be on when the photo barriers and the door of the machine are not open. A flashing 1-second pulse is used for the red light when the green light is not on. Our yellow light is on when the door open permit is energized. Counter 1 is used for the Conveyor 1 sequencer. When the hood of the car is present, the sequencer will cycle through the 6 steps without activating the robot or Conveyor 2 sequencers. If the quality is not good and the hood is missing, bit C0 will be set internally. When the robot sequencer is at step 6, a move instruction is used to the Do-More PLC to set the sequencer number of Conveyor 1 This will send the empty carrier out of the quality inspection station and reset the sequencer. Rung 10 will control the outputs associated with the Conveyor 1 sequencer. You will see this is all based upon the Counter 1 accumulator value, which determines what step we are on. C0 is set if the quality inspection fails to see a hood on the car. The Do-More counter of the robot sequencer will use 2 timers. This will allow for the movement of the robot to start before looking for the movement finish input to the Do-More PLC. Outputs are controlled by the robot sequencer accumulator. If you see that the timers used in a Do-More will have multiple parallel rungs for their activation. Rung 13 has a counter that controls Conveyor's 2 sequencer. Note that the first scan flag is used to reset all the sequencers used in the ladder logic program. The first scan will activate when the power is applied in run mode, or the Do-More transitions from program to run mode. The timer used in the last step is to allow the courier of the car body to exit through the photo barrier. Our Do-More ladder logic is complete. Call up the system configuration in the Do-More Designer software. This is done by selecting System Configuration from the main menu, PLC System Configuration. This will show us the current IP address of the Do-More Designer Simulator and will ensure that the Modbus TCP server is enabled. The IP address is the same as the computer it is running on. Ensure that you transfer the program to the Do-More Simulator PLC. Step 5. Test the program. We will use Modbus TCP on our Do-More PLC simulator to communicate with the EasyPLC machine simulator. Call up the Product Quality Verification Machine Simulator in Start mode. The status of the machine simulator will be at the bottom of the screen. Currently we have no PLC connected. Select I/O drivers on the middle bottom of the screen. The machine simulator I/O number will be displayed. Ensure that we select more I/O than the number required for our product quality verification machine. The EasyPLC driver is selected by default. Under the driver pull-down menu, select Modbus driver. This driver will communicate Modbus TCP or Ethernet and Modbus RTU serial. Select the Configure button. We can now enter the information for our Modbus driver. Select TCP IP. This means the Ethernet port of our computer will communicate to the Do-More PLC simulator. The digital inputs from MS to the Do-More PLC will be MC1 to MC33. This will start at address 0 due to the offset of 1. Digital outputs from the MS to the Do-More PLC will be MI1 to MI33. This will begin at address 0 due to the offset of 1. The analog inputs will start at 0 and will be 5 registers. Analog outputs will start at 10 and will also be set for 5 register. This means the quality verification number, or second output, will be addressed as MHR11 for the camera output due to the offset of 1. Select the OK button. You will now see the inputs and outputs specified for the Modbus driver. We can now manually assign the driver outputs to the PLC inputs and driver inputs to the PLC outputs. However, the automatic assignment works well and will save you time. Select Automatic Assignment from the driver option in the main menu. This will automatically assign the PLC I/O to the machine simulator I/O. Select Start Driver and exit from the main menu. On the bottom left side of the window, the driver communicates with the Do-More PLC simulator with a green light. Select View I/O to know the inputs and output status of the machine simulator. Ensure that the Do-More PLC simulator is in run mode. We can see the operation of our product quality verification machine. The digital inputs and outputs of the MS will correspond to the PLC controller. Using the Data View window of the Do-More Designer programming software, we can also watch the inputs and outputs operation. Using Machine Simulator MS to test the program will ensure that our program works. Troubleshooting is quickly done without damage to any physical hardware. You can practice your modification and debug by modifying the Quality Visual Inspection and Do-More program in the following way. Add a control panel with Start-Stop buttons. Add a jog button for each sequencer in the control panel to sequence through the steps. Calculate the rate of quality car parts coming out of the quality visual inspection machine in parts per hour. Calculate the rate of good versus bad quality parts per shift. Let me know how you made out in the comments below. If you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.